we're going to be talking about determining performance of the R-22 helicopter. There's a few things that you really have to keep in mind when you're determining the performance of your helicopter. Number one is the pressure altitude. Number two is the density altitude, and then out-of-ground effect versus in-ground effect hovers. Pressure altitude is your true altitude, the height you are from the ground, corrected for non-standard pressure. So standard pressure at sea level is 29.92, and then to get the pressure altitude, you're going to roll your altimeter down until it says 2992 in the little box, and then look at the dial, and the dial is going to tell you how far above or below standard pressure you are. You can also get this from METARs or from your weather reports when you're getting weather right before you take off. Density altitude is pressure altitude corrected for non-standard temperature. So standard temperature at sea level is 15 degrees Celsius. And so what you do is you take pressure altitude and correct for non-standard temperature. The way that we do this is we go to our POH to the density altitude chart. So get out your POH and we'll take a look at that. Mine is right here on my iPad. And as you can see, density altitude chart. And what we're going to do is we're going to start with the temperature that is outside. So we'll say it is a 4-degree day right here. And then we're going to go up until we get to the altitude that we're wanting to check. We'll say 4,000. So we're going to follow this up until you get to the 4,000 mark. And then you're going to come sideways to the left-hand side, right here, which would be 3,500. And that's where you get your density altitudes. These are in thousands of feet. You can also get density altitudes. They give it to you a lot of times at the airport in the weather reports if it is something quite a bit off of standard and they want to make sure that you know it, or there's many places on the internet you can go and look what the exact density altitude for that airport is. Now, out-of-ground effect versus in-ground effect is really going to determine what you can do in your helicopter, where you can go, and whether you're going to be able to get in or out of that helicopter. So here's the situation. There's an airport at 8,000 feet. They want us to fly our helicopter out and take some aerial pictures of the airport so they can hang it up on the wall. So we determined that our helicopter, MSL, our helicopter weighs 1,200 pounds, and this includes fuel, it includes the pilot, and it includes the cameraman and any gear that he has. And we'll make it easy and put it standard 15-degree day. And so the way that we can determine in-ground effect and out-of-ground effect charts, again, it's in Chapter 5 of your POH. So flip to Chapter 5 of your POH, and let's look at the in-ground effect hover charts first. So here's the in-ground effect, just like the one that you have. As you see, you can read up at the top, in-ground effect, 2-foot skid. So this is going to be good only for a hover right on the ground, and it determines if we're able to get into the airport and to land. So on this one, we start with pressure altitude over here on the side. As you see, our airport is at 8,000 feet, and then we follow it over until we get to the temperature. So there's our 15-degree day, and then we follow it down to figure out how much weight we can carry at that altitude and temperature. In this case, 1,300 pounds. Since our helicopter is 1,200 pounds, we can get there, we can get an in-ground effect hover, and we can land at the airport. Awesome. Now, the other thing that we're trying to figure out is if we can get above the airport and hover so the cameraman can take a picture. What we use to use that is our out-of-ground effect hover. So as you can see, out-of-ground effect hover, this means we're more than 30 feet off the ground and we no longer have ground effect. And so our out-of-ground effect hover chart, or OGE chart, works much the same way. We're going to look at 9,000 feet now because we're 1,000 foot over the airport and trying to take pictures. We're going to go to the 15 degrees and then follow it down. As you can see, in this case, we can only carry 1,140 pounds. Since our helicopter is still 1,200 pounds, we're not going to be able to stay in a hover out-of-ground effect to do this. And so we wouldn't be able to go and take that flight unless the cameraman was willing to take pictures on the move. But we're not going to be able to stop or slow way, way down so he can take a nice still picture. In this case, probably not the best idea to go try to take those pictures. Maybe you could wait until early in the morning or pretty late at night when our temperature drops, and then that gives us a lot better performance. So this was determining the performance of your helicopter, how to find pressure altitudes, how to find density altitudes, and the difference between out-of-ground effect and in-ground effect. Thank you very much.